Welcome to the cadCAD community call. And we have a lot of partners today. So this is kind of a culmination of a couple different token engineering community partners, the Token Engineering Academy, BlockScience Labs, BlockScience as well. So the agenda for community call 16, we're just going to do a quick hello from the organizers, mention everyone that's out there, and then obviously get into the good stuff, the cadCAD 1.0 announcement. We'll have time for questions and discussion, and then we will get into the BlockScience Labs demo as well, and questions and discussion after that. Cool. So I think I already mentioned it, but we have a big group of partners supporting this call today. So it's really cool to see the unity across the TE space. BlockScience Labs we'll hear from later today. BlockScience, obviously, a really awesome engineering and research firm in the token engineering space, has added a lot to the cadCAD community over the last few years in developing the tool. So shout out to BlockScience, and then obviously the Token Engineering Academy as well. I think a lot of you have probably taken programs from the TE Academy, and so it's great to see you here. I am also here partially representing the TE Academy, so I get to give a little plug for this organization for anyone who hasn't had the chance to join our education programs. But just for a quick intro, the TE Academy is offering structured education for token engineers, and the overall mission being to develop the new engineering discipline. So I think everyone here loves to see the open science values practiced, and has probably participated in the research programs. And it's really cool to just be able to do this research in a little bit of a structured way where there isn't much structure in the space at the moment, and very openly to grow and advance the field. And then obviously educating aspiring token engineers as another big initiative. We've had a lot of courses so far. Most of them are research programs that last about 3 months. We also have these introduction to token engineering sessions monthly, and study groups that meet weekly, but all focused on structured education for token engineers. So we'd love to have you join. And coming soon, a little sneak peek on an announcement for later in this program today is a cadCAD study group. So we're going to be organizing and coordinating a study group for token engineering community members to start working on cadCAD models and contributing to the cadCAD community, because with this announcement, I think there's a really big opportunity to start coming together on that front too. And we'll send a quick registration link later in the call. And then finally, the last plug for TE Academy is TE Fundamentals. So we're currently working on the first comprehensive education program in token engineering. This is a really exciting initiative. It's been supported by a proposal in the TE Commons already, and we have some other great partners supporting with the development. And yeah, it's going to be the first bachelor level education program for token engineering. And we're really excited to be developing the content right now. We're hoping to launch near Q3 of this year, so coming up fast. And yeah, if you're interested to learn more, I'll also share a link in the chat for the AMA session we're hosting at the Token Engineering Commons on February 4th, which is in 2 days already. So I'll share that link in the chat. But this is the big program that we're really excited about for this year. So yeah. And finally, we get into the good stuff, cadCAD 1.0, after that quick hello. So I will now hand it over to, I believe Chris Catoya is jumping in first yeah.
Thanks. Thanks for that introduction, Peter.
Yeah, you'd like to share your screen, I think?
Yeah.
Cool. I'll let you go with that.
Okay, now I can share it. Cool. My name is Chris Catoya. I've been acting as executive director for the cadCAD Foundation, and I'm also product manager. at BlockScience Labs. I'm really excited today. cadCAD 1.0 represents everything we've learned about what cadCAD as a tool needs to be over the last 3 years, as well as it represents all the work that all the collaborators for cadCAD have done over the last 6-8 months, thinking about what does the evolution of cadCAD and the community need to go for the next steps. So I want to thank everyone that is here on the call, and I want to specifically thank Tyler Mace, Michael Zargum, Josh Jodeci, Jeff, Emmett, Jessica Zartler, and Peter Hacker for helping us put this call together. If there's any other names I forgot, I'm terribly sorry. There's just a lot to get forward. So what cadCAD 1.0 represents for us, I just want to go over sort of at a high level what our goals are. And then I want to pass it off to Tyler to talk about sort of the developer improvements that this represents. And then Michael will cover the sort of technical meat and the design changes and some pre-production code of what cadCAD will look like. So at a high level, we wanted to increase the legibility and reduce the friction for people modeling and getting into the space. We also want cadCAD 1.0 to be the reference implementation and set as the validation benchmark for all other use case specific, language specific implementations of cadCAD. And we see this as our way of being able to grow the cadCAD community. Something that is sort of a fundamental principle for us is we see cadCAD as a tool for improving epistemology in the public space. So how people know what they know, being able to share their models and talk about what they believe the world to be, we think is fundamentally important in the world today. And we view cadCAD as a tool for people to do such. So when we talk about increasing legibility and reducing friction, what I mean is making it easier to build models. That includes sharing, collaboration, and reuse with some modularity. Z will be talking about this in greater depth. And there is a nice synergy between this point and BlockScience Labs, and we'll be able to talk about that a little bit later today. So excited to hear more on that front. And we wanted to minimize the amount of boilerplate. I think this is something where people have seen there's code, you just use it, maybe not understand it. We want to reduce that. Tyler will be talking about this at more length. One thing we've realized is we needed to separate out what it means to build a model and what it means to run a model. And this allows us to focus a lot more on a friendlier experience for people just starting their systems engineering journey. And all of this is supported by having a well-documented implementation. So as a reference implementation, people can validate additional implementations against this, and it can be certified that it is cadCAD. It is cadCAD compliant. And what's nice about having this reference implementation that is stable, it can be the community focus point for us talking about what is cadCAD and talking about improvements to cadCAD methodology. And we want to make very explicit that this embodies the mathematics that are described in generalized dynamical systems that is done by Jamshid Shoris and Michael Zargum. And we hope that all this can foster more community development on additional implementations as well. So we've already seen examples like RadCAD that Ben put together. So being able to grow the community is really important to us. Having a stable API, we think will enable this. We want to start seeing an open library of more models, demo models. We have some, love to see a proliferation of this. And now with modularity, the ability to have modules themselves be a library built for that. We'd love to see people being able to build out extended functionality and tooling for various implementations. And as I've already said, more implementations. The other tact for this is building out, being able now to build out partnerships. So as we're here today with token engineering, we're really excited by that. And we want to just continue that sort of strategy. So who's involved with cadCAD? It's a little bit of a complex ontology, so I wanted to lay out a bit of the landscape here so we can connect some names to faces and know the relationships between all the different orgs. So we have the cadCAD Foundation. We have BlockScience, which, as Peter already mentioned, is a R&D firm. They built cadCAD to do the work for their clients, and they've been generously supportive of all the cadCAD work. It was founded by Michael Zargham. And most of the researchers that are involved in the cadCAD community, a lot of them come from the BlockScience space. Then we have BlockScience Labs, which was a spin out from BlockScience as an open core SaaS offering. Chris Frazier will be going in more depth about this a little bit later today. And the goal is a platform that will make using cadCAD easier and more sort of professionalized in production settings. We've seen organizations already spring up, like cadCAD EDU, to help come in, step in on education and helping people ease into the ecosystem. So we're really grateful for all their efforts there. And we have Token Engineering Academy, which is, you guys are already doing cadCAD study groups, and we really are super excited to have a deeper partnership and integration there. So I've mentioned a couple times different implementations. One thing we've realized is having more use case specific implementations will improve the experience, improve the ability of the community to sort of coalesce around specific projects. So what this represents at a high level, our roadmap is the current 0428 release of cadCAD. We're going to start designating as legacy. It's the thing we've all been using. It's in Python. It's not going to go away, but we're looking to move away from development there to focus on 1.0 and what we're tentatively calling professional. So 1.0 is the reference implementation. It's in Python. It's built from a blank canvas. We are designing this from the ground up. And cadCAD Professional is currently being built by Emmanuel Lima, who works at BlockScience. It's in Julia. We're looking to have potential interoperability with Python and potentially JavaScript. Professional, the idea there is to really focus on the execution of model simulations. So it's going to be focused more on big data science workflows. What we're intending is there is a path of mastery from 1.0, which is everything you need to just express what a model is at its core basics, and then upgrade to professional when you have very specific cases that are more about larger models and things of that nature. And the idea is that you could just import your 1.0 model and run it in Julia, because Julia is a metal programming language. And then last but not least, cadCAD Experimental. This is just representing experiments that we're doing to learn more about what are improvements we could make to cadCAD. We see a sort of Cambrian explosion of a bunch of implementations as the best way for us as a community to learn what are the best aspects of them and to figure out how we want to improve cadCAD in the future. So cadCAD Experimental right now is represented as a Rust implementation, and what we're trying to do there is learn a little bit more about what it means to build in a language that has strict typing and borrowing and memory management. So last but not least on this slide is we're expecting to launch 1.0 sometime late February. So just some quick status updates on the cadCAD organization itself. We've incorporated, we're currently applying for nonprofit status. We're investigating moving from the Aragon wallet to a Gnosis safe. Gnosis seems to be better suited for a multi-sig wallet and management of funds for like our bounty program in this fashion. So that's a movement we're looking to do. And about the bounty programs, what we've learned is it's actually really hard to set up bounties in the way that we initially set up. So we are looking to do partnerships to get that moving along. The first is with Token Engineering. We've seen that the study groups have been really successful, and we want to utilize that format. There's some details to be determined, but if you're interested, you should sign up with the registration form that Peter has shared. And then we're also partnering with BlockScience Labs to encourage the development of labs platform specific models that are ready to run there. So if you're interested and you want to stay updated, definitely follow the GitHub. We have a Discord, and we have several bi-weekly calls on the calendar. One for called Core Tech, that is for working on the engine itself. We have Infra and Admin, that is more in terms of tooling around supporting the community. You can also follow our Twitter, and we will also have a Jira or ZenHub set up that will show the roadmap of the work that we are doing. So if you're curious on what needs to be done, how you can help, we want to have that very clear and legible for people to know how to step in and help right away. So I want to hand it off to Tyler right now, and he'll talk about the developer improvements that 1.0 represents.
All right, can you hear me okay?
Yep.
All right, so yeah, I like to think of this 1.0 release as having two primary objectives. I think probably the biggest, at least the one that I'm the most excited about, is along the lines of improved UX. And I think that a lot of what Chris just went over sort of highlights some of those areas that we've been thinking about over the last month as we've designed 1.0. We've excuse me, we've had 2 years, the better part of 2 years, to work with cadCAD Legacy to sort of figure out what works and what doesn't. And there's a lot of complexity in how you craft or construct your model. But on top of that too, just using the cadCAD engine itself in some places is a little over complex. And so what we wanted to do with this 1.0 release was really focus or sort of revisit how users are going to be interfacing with the engine, how we're going to be designing our models, how we're going to be running them. And so most of my focus over the last couple of weeks has been around trying to redefine an API that is intuitive and easy to understand, and makes it so that there's not a lot of boilerplate that is misunderstood or maybe not understood at all. So that's been kind of like one of the primary pushes. The other thing too is that the other objective that I was talking about is that with this sort of redesign in the architecture, we are able to, I guess you could say that we've enabled a new way to model. We've kind of shifted to a new paradigm that we hope will lend itself to just improvements in code reuse, organization, and that modularity is a result of the re-architecture, right? So those are kind of the two big things that we're getting out of this. A lot of it has not been set in stone, I guess, but we have a really good idea of where we want to end up, and we're continually working towards that. So yeah, let me just talk real quick about some of the community type stuff that we're doing too. I think that that's a really big deal. This kind of goes hand in hand with what we have done around the UX, but in improving the UX, one of our main objectives is trying to make this easier for new people to onboard into the cadCAD ecosystem, whether that's designing models or just running something and generating some useful information or data that we can do something with. So around this, we're trying to solidify some of the processes that in kind of tandem with this UX revisit. I'm trying to improve the UX. We're also trying to solidify a lot of the processes around onboarding people into the community, getting them using cadCAD, documenting how cadCAD works, how to think about systems, how to model systems, and then also around contributing to cadCAD, not just being an active user, but also a participant in the software. And that's been a pain point for us as well in the past, where we just haven't had well-defined or well-established processes that were easy for people to sort of jump into and contribute to cadCAD. And so we've done a lot to identify where people are struggling to contribute as developers, or maybe, you know, just building stuff on top of cadCAD. And you know, one thing that we talked about a little bit earlier, Chris sort of touched on, was this bounty program. From a high level, it seems pretty trivial to, you know, create these bounties to sort of encourage new things to be built, but it actually turns out that's a fairly difficult thing to divvy up that work into a unit that you can just hand off to somebody and then sort of reward them for. But that's an example of one of the processes that we are hoping to improve upon substantially with the 1.0 release, just to make the onboarding and the community development around it a little bit better. So, yeah, I don't think there's anything else that I need to go over. So we could probably hand this off to Z at this point, unless there's something else, Chris, you wanted me to talk about.
Yeah, just touching real quick on sort of the documentation work we're looking to do, semantic versioning, the legible upgrade paths I think you touched on.
Sure. So yeah, the documentation's something that we're continually thinking about. I've mentioned this before to some people, but doing a rewrite from the ground up is giving us a really good opportunity to write this documentation as we go. And we're also broadening our scope as to who the documentation is for. We really want to have documentation that, you know, provides useful information to a bunch of different types of participants of the community, whether they're just using cadCAD to run some models or they're developing models. And then, you know, all the different backgrounds of these people that are involved in the community as well, whether they've got the math background or the control systems background, or maybe they're just designing an economic system for some, you know, blockchain based environment. We want to have documentation there that sort of explains what cadCAD is, how it can be used, and so that will include code snippets on how to use cadCAD, how to model, but it will also include things like some of the theory, the mathematics, so that there is something there for everyone. Another thing about the documentation too is we're doing a better job of consolidating it, putting it into one spot. This has been a problem where we've had everything basically documented at some point, but it's been kind of spread out all over the place. It's been kind of hard to aggregate that into a single place. So we're really focused on trying to have a one-stop location for all documentation. On top of that, I'll just touch on this briefly, but semantic versioning is something that we just didn't have in the initial version of cadCAD. And that's made it so that the upgrade paths were kind of tricky, difficult. You didn't always know what you were getting when you made that upgrade. And it also made it kind of hard to reason about the version of cadCAD that you were developing against. And so we wanted to make sure that with this 1.0, everyone understood that we were implementing semantic versioning. So some of those pain points should go away. We want you to have some confidence in what you're upgrading to and understand your upgrade path and whether or not a particular upgrade is appropriate for you. It's probably also worth mentioning too that there's some additional tooling and stuff that will be released around the same time as 1.0 to help with just general development. An example of this is the cadCAD CLI, which is a tool that we've developed to help scaffold new, empty, or models with very basic structure to them already, so that there's not this process of reinventing the wheel every single time. Now, even though the API is being improved to a point where there won't be as much boilerplate as there has been in the past, I still think for larger models, it'll make sense to scaffold so that you don't have to, go through that same 10-step process or whatever it is, getting all the files and the empty files in place and naming things in a consistent manner. This scaffolding tool will help take care of that. There will be more information about that tool in the future, but just worth mentioning that that's also something we're working on. So.
Awesome, thank you, Tyler. I think now we're ready for Z to take it away.
Sweet. Do you mind if I screen share so I can paste? Yeah,
Please.
sweet. I'm gonna go. Oh, I have this open twice. Yeah, whatever. We'll make it work. Slideshow. Can you see what I am sharing?
Yep.
Yes.
Cool. All right. So I'm going to talk a little bit about what we've actually done with the redesign, and I'm going to focus that on why cadCAD 1.0. Obviously, the goal is a better user experience, but this is somewhat, well, you all know cadCAD is quite complex, so I'll start with a review of sort of what we've experienced with Legacy. The APIs and models or the approaches for building models and running models are sort of entangled with each other. This creates a challenge because the needs of a person building a model and a person executing a simulation are not really the same. Even if it's the same person, you're actually doing different stuff. And when you put those two things together, it actually reduces the clarity, it reduces the ease of use. So we're going to be untangling at least the user stories that we're developing against, and ultimately the features associated with building and running models. We are trying to make sure that even if these are different people with different skill sets, they can work together effectively. The current framework has lots of boilerplate, as Tyler mentioned, that reduces legibility and adds friction. And we often saw models breaking when we versioned. We really need to get away from that. We also, and this is really a big part of what we're doing now, is we're not seeing reuse of model logic. It's very difficult. You could reuse the mathematical concepts like something like a payoff matrix or an AMM, like a lot of these, constant function market makers, a lot of the math and equations got reused, but we actually had a lot of copy pasting and re-implementing and not a whole lot of, components that could be imported and reused. And so we want to move into a direction where things are a lot more modular. The models themselves are actually iterable so that you can do scientific experiments on them. And so this is sort of our motivating example. I have a model of a spaceship, a model of a tower, and now I want a model of my spaceship crashing into a tower. Like, we want this to be relatively straightforward. You should be building a model by connecting the two models, and there may be some things you need to do where they touch, but actually you're not going to change much outside of the places that they interact. Now, interact in an information system looks a little different than interact maybe in a purely physical system, where you can localize the point of interaction in the way that this drawing does, but in practice you can identify the places where those interactions are changing, and we want to make sure that our software respects that kind of modularity. So to kind of make this concrete, I'm going to give this example, but first I'm actually going to say the underlying mathematics of cadCAD is generalized dynamical systems, and generalized dynamical systems are expressions of basically computation logical chains looped on themselves. There are data structures. Those data structures are organized potentially into, keys and shapes. So in mathematics, we have things like real numbers and integers, and we can, pick which kinds of object we're working with, and that will affect what we do. In computer science, we have types, and we might be dealing with, at the lowest level, things like we'll be dealing with bits, but at higher levels, we're dealing with, these strongly typed objects, and even user-defined classes. So we're going to define this concept called a space, and a space is really kind of inheriting from mathematics, a collection of dimensions where each dimension has a type. we will really use the concept space as more primitive, because a block is simply an input-output transformation from one space to another space. One of the great things about this is that it makes everything really modular, and it actually matches up with the way that systems and control engineering approaches things, and some closed source softwares that we sort of take some inspiration from, but we want to open source tooling for, use sort of the composing of systems via connecting blocks. In this case, a block is an input-output logic with a strongly typed input and strongly typed output, or at least we'll say firmly typed, because we have some tricks that we can pull in cadCAD and in Python, so that we are declaring we're declaring something explicitly, but that contains some freedom further down. For example, I might put a dictionary or something in here, in which place like what's underneath it could still be underdefined. But broadly speaking, we're talking about our model being made up of a world, and that world has spaces and blocks that represent transformations from one space to another. And then we have wirings that wire this together. And that's it. The whole system is just some spaces, some blocks, and the wiring rules. And the wiring rules are reminiscent of the function the p-sub objects fulfilled in Legacy. It's just that we were a little overstructured about what wirings were allowed. Now we have a well-defined grammar that just says, look, like you got spaces and you got blocks, and you can plug them together or wire them together as long as the spaces match. And so there's some elements of functional programming in here, but there's also some elements of object-oriented programming. And so we're being careful to take from the actually long-standing systems and control theory field for block diagrams and their role in system modeling. To make my point, though, about modularity, let's suppose that process number 2, which is here exogenous, something that happens in nature, was to be made endogenous. I simply want to keep everything else the same, but now instead of this being a random behavior, it's a strategic behavior. The only change that I should have to make to this system is this. That one block changed and I added a wire. Nothing else in this system changes, because by iterating from process 2 to process 2.1, I have introduced a new block, or a new instance of a block, that maps from the space D to the space E, and I've connected the space D because there was already a value coming through this process. This GDS already had a value of D on every iteration, but previously it was not an input to process 2, so I have redefined process 2 as 2.1, and it still outputs E, and it still feeds into process 3, but it has D as an input. So we've changed one block and we've added one edge in the wiring rules. This is what it means to do modularity in like a systems engineering context. And although I've represented it visually here, I will show you what these wirings look like in cadCAD 1.0. Before I do that, though, I want to show you what a real life problem kind of looks like. So this is a version of an iterative prisoner's dilemma that's a bit more representative of real world decision making problems. So I'll go through how I got here in a second, but I'll just tell you what this diagram represents. You've got Alice and Bob in a let's say in a contracting type of engagement where they both sort of see the possibility of benefits from cooperating, from working together, but it's not immediately clear to them what their payoffs are going to be. They might have some prior estimates, models of the world that they use to make their decision, but we're going to frame this as a repeated game, so they get to kind of decide whether to try to collaborate with each other, and if they do, there'll be some outcomes, and then they'll update their model and they will iterate. Now, couple things that I've done here that are not normal for a prisoner's dilemma that make it more realistic is that I've taken away a priori knowledge of the payoff matrix. So this payoff matrix setting process points to the realization block, but does not point to the decision processes. You do not actually know them. The only thing you know is your world model. I have left their world models totally abstract. They could be different from each other. It could be as simple as a bit or a process that resolves to a bit. I trust you or I don't trust you. It could be a process that resolves to a continuum. probability that I think you will cooperate, or really any other model. And Alice and Bob's models of the worlds do not need to be the same. They each have their own space. So Alice's space is a signal, sort of script, bold, capital A, and I've left that arbitrary. Alice's model of the world is a thing that takes Alice's signals she can observe, her previous decision, her payoffs, and Bob's payoffs, and computes an updated estimate of the world, and then uses that estimate of the world as an input to Alice's decision process. This is pretty standard in estimation and decision in a formal setting. You separate the estimators from the decision makers. And here we have said that Bob and Alice are both doing this. They're capable of learning, but they don't actually know what the other person is doing, only the outcomes or the consequences of what the other person did. And now they're going to continually decide whether or not to cooperate or defect in our little 2x2 payoff matrix. And a reason I emphasize this is because when we're really dealing with real world systems, we got to get away from some of the highly stylized academic economic models, but they're not a bad place to start. So some of the modularity in cadCAD 1.0 is meant to help people get to things like this from things that they're more familiar with. So here I could model a one-shot prisoner's dilemma where I give both players access to the payoff matrix. I let them compute the Nash equilibrium if they want to, but then they make a decision. The decision goes through the payoff matrix, and then I'll just collect up the data. And really the space at the end is just a space that's an aggregate space. It collects up the information so I can loop it back around. When I go to a repeated prisoner's dilemma, which is the second one here, now I'm basically saying that all that information is available, and so my agents might decide what to do. And at this point, I could implement something like tit for tat, or I could do a ultimatum strategy or whatever I want for Alice and Bob and see what happens. But they have visibility into the previous previous outcomes through this feedback from the space in yellow. This is a pretty standard model for teaching. Doesn't really represent real life very well, but it's a good model for starting to learn how to write simulations. I will note that it's also got the awkward property that it's pretty static, that there's not a lot of information that goes round over round. Anyway, so then the next thing that I did was take away knowledge of the payoff matrix. So at this point, I would have to actually change the decision-making processes, because if they used information previously that I had given them, I'd wired in, that code would break. So I would have to go back and actually update Alice and Bob's individual decision-making processes or strategies to not depend on the payoff matrix, because I have actually rewired it so they don't have that information anymore. So there's a minor wiring change and changes to those two blocks. But again, nothing else is being changed. So the goal here is that each step is moving from one representation to another representation with minimal change. First change added a feedback loop on the wiring and meant that we could slightly change the strategies to account for the old information. We have a next one where we remove some information, and that means we have to slightly change the strategies to ensure they don't use the unknown information. And in the third one, I further remove the explicit observation of the other player's action, and I replace it with some sort of estimation, and it's different for each player. They can have their own estimation process. But once you've moved to the explicit estimation process and decreased the overall observability of the problem, that's where you get back to something that actually looks like a real life decision problem. It's still a model. It's not a perfect representation, but it's the kind of model that you can use to actually do estimation, automation, design, digital twins, etc. Because now you have a sufficient level of complexity that at least you can imagine that your conclusions are going to help you make decisions in real life, rather than just give you intuition, which is really all you get if you are sort of, let's say, overly assuming that people know stuff, which is common. Anyway, so this is a demonstration of how a modeler might go from a system that is relatively straightforward and standard to code, like a one-shot or a repeated prisoner's dilemma, and work their way up to something that's representative of a real-world design or analysis problem. And then in order to get to code, I'm going to go to an even simpler problem. I know I'm still giving you drawings, but I'm trying to build some intuition for this block and space way of approaching things. This is going to be a spinner example, but I have a discrete coordinate system. It's going to be just integers on a grid, and I have a value in that space. It's the space that's labeled 1, and it's literally just x and y are integers. Then I have a Cartesian to polar coordinate transformation, which will basically solve for the radius and angle, and that will give me a point in space 2. But then once I'm in the point in space 2, I'm going to apply a rotation, a random rotation. And then I'm going to get a new point in space 2, and I'm going to transform it back from Cartesian to polar, or excuse me, from polar back to Cartesian. So I have 3 blocks in this model and 2 spaces, and I have a closed loop dynamic because I'm going to repeat this. I'm going to take my space in the XY grid. I'm going to convert it to polar coordinates. I'm going to apply a spin operation in polar coordinates that changes the angle randomly. I'm going to transform it back to Cartesian coordinates. But if you notice carefully, this is lossy. If I were using real values all across the board, I would have a sort of perfect matching between the 2 coordinate systems. But because of the discreteness in the space 1, actually the transformation from the polar to Cartesian is lossy. And we're going to actually see what the consequences of that lossiness is in this example. So first off, I defined some spaces, and this is from the prototype code that I wrote. So I wrote some class-based, like pretty basic Python cadCAD 1.0 prototypes. So this class space is a collection of dimensions, and I initialize it with a name. It's empty, and I just give it 2 integers. And so now I have my space 1, it's made up of x, which is an integer, and y, that's an integer. And I make my space 2, which is floating point polar coordinates, and I get r and theta are floats. And although this is a really simple demo, there are lots of things you can do to make spaces richer than just types. They can have metrics, constraints, and some other functionality that could be really important for designing and testing systems. But at the most basic level, you just instantiate a space and you give it what you need it to have. In this case, I gave it 2 dimensions, x and y. The second space, the dimensions r and theta. And I've effectively created this thing. I instanced an object, which is called space, which is actually a collection of types. So it's in this weird zone where it's not quite a class, but it actually behaves a bit more like a class, because what we really care about are points in the space. And we're trying to avoid this common, more computer science conception, which would say that it's a set. A space isn't the set of all points in the sense that we enumerate them. It's the set of all points in the sense that anything that satisfies the rule is a point in the space. So it's actually still an abstract object. It's any pair of integers x, y, which is different from saying it is a list of integers, or excuse me, a list of pairs of integers x, y. All right, so we declared our spaces. They're relatively simple objects. They provide us some typing functionality that will allow us to build our block diagrams. So the next thing I do is I build two blocks. You can look up the logics for polar and Cartesian transformations on Wikipedia. They're pretty simple. And here, with the caveat that as written, you can't interpret the blocks as input, output, left to right. You actually need the arrows to interpret them. So it might make sense to refine some of the drawing logics to be clear. But the idea is that Cartesian to polar takes a point in the space Cartesian and returns a point in the space, well, so I guess space 1 and space 2. The Cartesian space is S1, the polar space is S2. And what this is doing is providing you a function that maps from one space to the other. If you give it a point, it will give you a point back. But back to this idea that the blocks don't care yet about the points. The wiring rules ensure that this will work, but it hasn't actually done it yet. And a big part of the system modeler's job is to be able to put this thing together even before you have points. And that's part of what makes it difficult, and difficult from a coding perspective. So we build our blocks by simply declaring logics and then putting them in this object block, which says my block takes in a point in space 1, it returns a point in space 2, and it does so using the function to polar or the function to cart. And I've just boxed these things up, but in doing so, I've made them reusable. If you had your own model and you needed Cartesian and polar coordinate transformations, as long as you were able to sort of reuse the same spaces, you could also reuse the same blocks. And there's some other concepts related called subspaces and projections, and these are concepts that will have to be available to engineers and modelers to make things fit together nicely. But on the whole, you can imagine that as long as the kind of space you're using is something you would reuse, and the kind of transformation, the block, is something you would reuse, blocks and spaces are things you could actually import and actually reuse, which is one of the big weak points in the legacy cadCAD. So finally, in my example, I'm going to add one more block. It's the spin block, and then I'm going to wire this together. And all I've actually done here is declared one more block. Then I wrote a list blocks of blocks, applied a method called series, which does a composition. What it's saying is, here's how you wire it together. Wire them together in a loop. Now, the tricky thing is that when I did blocks and spinner, spinner series is these blocks, but it doesn't close the loop. It would actually just go from Cartesian to polar to polar to Cartesian, but it wouldn't actually connect and close a loop to be able to repeat. When you actually close the loop, you're introducing time. You're saying, aha, but I'm not at a totally new place. I'm in the same place in a new time. And that is effectively what a dynamical system does. And so when we take this thing that goes from the space 1 to space 2 to space 2 again, back to space 1, so now that we've gone from space 1 to space 1, we can make a dynamics. And it says my state space is space 1, and my block, the rule that I'm going to use, is called spinner, keeping in mind that spinner is actually the wiring of those 3 blocks together. So when I've done this now, I have a system. I have officially created a dynamical system. It has some abstract properties. It exists in code, but I have no points yet. Of course, if you're an analyst or an engineer who's using this to do simulations, you need to make points. And you want to look at what those points are, but potentially you want to look at those points under lots of different conditions. So we support initial conditions and parameterizations and some more advanced features. But at the base level, you're closing these loops as dynamics, and then you're just running a scenario. Let's say we start at position 30, -30, and we click go. So here I've created an initial point. So xy_in space 1 dot point, and then I assigned it some values. So I used a dictionary to tell it what point I wanted. So I've created a point in space 1, and I've said, all right, I want a trajectory. A trajectory is a sequence of points. And so it's really just a list of points, but it's a list of points with some extra functionality. In particular, if I take this trajectory and I say, well, I have a point and I have some dynamics. So now I've given it the dynamics object, and all I basically want to do is say, okay, well, what do I've got? Well, if I haven't applied the dynamics, I've just set them, then I'm going to have a point. The initial point, the one I use to create the trajectory. But if I want to run a bunch of steps, I can say, okay, apply the dynamics 100 times. So because it goes in a loop, it just clicks through 100 times. And so now I have 101 points because I have the initial point, which was index 0, and then points 1 through 100 that were generated by applying the dynamics 100 times. Interestingly here, we already have something going on that we might not expect, because if we hadn't had the rounding effects from the integer nature of the grid, this would actually stay the same. We wouldn't be losing energy. So here you can kind of get the impression that something's getting lost because this converges to 0, despite the fact that the only thing I'm changing is the angle in my dynamics. So the cool thing now, though, is that we have these tools to switch coordinate systems pretty easily. So even if I have points that are in Cartesian, really it's not technically Cartesian because they're not real valued, they're integer grid coordinates. I can still use my blocks in post-processing. So I might want to transform it back into polar to see what's going on. And I can do that relatively easily. So here I've used in post-processing, I've reused my cart to polar transformation block to get a data set that tells me what the magnitude and angle is at each point in time. And I've used some plotting tools to show what's actually happening. So on the right is the scatter plot on the grid, and what's happening is that I'm doing these random rotations, but because the random rotations can result in points that are not integer, the rounding basically moves them to the closest point on the grid. And this will continue basically until the system runs out of energy. And it's pretty easy to see what's going on in R, which also brings us in radius or magnitude, which is part of the reason why we want to understand things like spaces, is because some systems have behavior in dimensions or spaces that are easy to articulate, but don't show us a lot of useful data. And other dimensions that are not the natural occurring ones, but are super important for understanding how things behave. This is also true of things like AMMs with constant function market makers, where most people don't really think about the invariants underneath them. But if you look at those invariants, you'll see really clear-cut behavior, even when all of the individual activities are quite sort of random and individualistic. So this is meant to sort of show you results from code. So I made this drawing, explained this rotational system, then declared the spaces I needed, declared the blocks that I needed, wired them together, then basically instantiated a trajectory with a point and some dynamics and let it run. And I got some results, and I reused my blocks in post-processing to understand what's going on. So I only really have one point left, which is that I haven't thrown away the underlying structure of cadCAD legacy. I've actually simplified it by saying that, look, anything you might want to model is a block diagram, as effectively can be thought of as a template. And so the standard P substructure is a stage game. It's a repeated stage game. And so we can still have this template because this is a wiring rule. But we want to have other templates too. So repeated stage games, one-shot games, dynamical systems that represent physical systems that are used to teach are often things like spring mass systems. But we don't want to force a lot of this stage game structure on systems that maybe they don't match for. So we'll be able to use things like the CLI to auto-produce patterns so that people can just fill things in, while at the same time not making people use that structure if their model is a lot simpler. So for like my simple spinner loop, you wouldn't need to do this sort of complex multi-stage game thing because it's not a complex multi-stage game. But you might want to use that for something closer. Maybe that prisoner's dilemma is a single stage game, but it has stages for decision making, realization of outcomes, and then updating your learning or updating your estimates of how the world works. That would end up being 3 layers or 3 P subs, and there would be some actions in each layer. So we would be back to something a little more like this once we do the wiring, and we're going to be looking at different ways to make the wirings easier to express, even as the wirings get complex, because ultimately all a model should be is some spaces, some blocks, and some wiring rules. And we want to make sure that those things are adequately modularized so that it's easier to code things and easier to iterate on things. So that's the end of my presentation. I unfortunately have to run away because I'm going to the advisory council meeting for NumFocus, which is my sort of contribution to the broader open source ecosystem at the moment. And we honestly heavily rely on the rest of the Python and also Julia open source ecosystem around data science and computational science. And actually that's a reminder that although I put integers and floating points in here, we've been playing with a bunch of user-defined classes, and I'm actually really excited. If someone wants to experiment, I'd love to see someone wrap a token space model, because the token space models have agent lists and they have some solidity based objects or things that blocks potentially that represent updates to the on-chain systems. And it would be really nice to look at how our modularity, especially around declaring spaces and blocks, allows us to wrap things from elsewhere. For my own part, I've played a little bit with wrapping more complex objects from GIM, which is a tool used in reinforcement learning. So I'm sorry to speak and run, but I got to run on. Yeah, it's on the hour.
All good.
But I'll be available for questions, async, and a bunch of the other team members here have been hacking away on this stuff. So, yeah.
Awesome.
Anything else?
Thank you,
Thanks,
Dargam.
Cool.
Yeah, Chris, I think we could do questions for a few minutes if we want to with the other team members. Otherwise, we could jump into the labs update.
Yes. Before we just jump into questions, I see Henrik actually asked a very appropriate question or raised a concern, and we do want to address that here. So, yeah, what does it mean? What do all these changes mean? What am I supposed to do about these changes? We're going to continue ongoing support for helping people with their models, right? So no one's going to get abandoned for a while. And what does it mean to convert these existing models? The simplified API means it's actually going to be easier to build. There's going to be way less boilerplate cruft to have to sort through. And in fact, what we're building has a tighter coupling to block diagrams. So if you're doing systems engineering, and if you've learned systems engineering from CAD EDU courses or any other courses, you have everything you need in order to, you should have everything you need in order to be able to build cadCAD 1.0 models if you have Python coding experience, which those courses cover as well. And the idea is with modularity, you'll have a library of modules to build from too. So if you build a piece up once, the idea is it's once and done, roughly speaking. I hope this assuages any of the concerns that were being raised just prior in the chat. So with that, I'd love to move to Q&A.
Yeah, and I would also just add, Zargam was mentioning just the power of open source and the importance of it too. And Henrik, your question about the community, developing a community, I think this could also be viewed as an opportunity to create a stronger community, because anyone that has models in cadCAD will be going through transferring or transitioning, and people who are now picking up cadCAD for the first time will be starting with the 1.0. So there's going to be a great opportunity to talk with other developers and users of cadCAD to work through any of this. And that's also the goal of the community calls too, to share community updates and connect with other community members and hear about their work. This has been like very presentation focused, but usually it's a conversation too about work that's going on, models that are being built, and it's a good time to share problems, questions, hack around with other users too. So I think there's a good opportunity to connect with other community members now. Cool.
Yeah, so I'd like to just chime in here a little bit too around that idea of maintaining community enthusiasm. So that's a really good point, and it's something that we don't take lightly. We understand that this is kind of like a Band-Aid being ripped off. It's going to be a little bit painful, but there's a net positive on the other side of this, and that's what we need, because going in the direction we were going with legacy just wasn't working. We did have a community, we do have a community around legacy, but we're finding that the community isn't growing like we would like it to. And part of that is because for most people trying to use cadCAD, there's enough friction there that their involvement with cadCAD is very temporary in nature. There's a high turnover. So we feel like we need to just address a number of things, and it's probably better to just do it all at once if possible. And so we're taking the opportunity to address a lot of the problems that we've had in the past, all in one fell swoop. So in the short term, yeah, there's going to be some I don't want to say struggle, but there is going to be a little bit of a learning curve. But the positive that we get out of this is going to be much better for everyone. As far as the 1.0 timeline, we're hoping to have something usable in our GitHub end of February. That's what we're shooting for right now. I can't give any concrete times or dates. There's still a number of things that need to be put in place before we can open it up, but that's what we're shooting for, about 30 days from now. I could go ahead and take Andrew's question too. The block spaces dynamics between programming languages. I actually think so. So what we're trying to do with this 1.0 is build a reference implementation that has not been built to be the end all be all for everyone. We don't want everyone trying to run every model through the reference implementation. There's going to be other implementations of cadCAD that are more performant or that address the concerns of a particular type of modeling that I think that we would kind of push people towards for specific types of work. But for general purpose, and especially in the context of education, the reference implementation that we're writing first in Python, that's meant to be, like I said, educational. It's meant to be general purpose. It should run everything. Might not run it well, but it should run everything. And it's meant to just sort of onboard people into the world of cadCAD, as well as being documentation for people who want to understand the process, but also other people who are interested in developing another implementation of cadCAD that has some new features built into it, or maybe is built in a slightly different paradigm to cater to a particular field, right? So as far as transferring between the programming languages, I think that will really come down to the implementation that you're using. As long as it adheres to the GDS system, the formal spec that Zargam has put together, then I don't see any reason why you couldn't sort of develop the model, and then really it's just syntactic translation between the different versions. On that note, though, I would like to say that we are doing a lot of work towards this idea of having compatibility between the Python version, the reference implementation, and the more professional grade version that will be written in Julia. The APIs will be extremely close, if not exactly the same, so that transitioning from the slower, less performant Python version to the more robust Julia version should be pretty minimal, should be pretty frictionless. Hopefully that answers your question.
I can't have the dialogue open. Are there any other questions, Peter or Tyler, that you're seeing?
Mark says 1.0 teacher application form. I don't know what you mean by that. If you're wanting to teach
cadCAD 1.0, I'd give a shout out for the study group interest form, because I think the idea is to all teach and learn from each other. So
yeah, can we maybe get a link? Whoever has that, can we drop that in chat so that it's there? Maybe it's in the Twitter thread. I can't remember.
The registration form is in the chat. I've also added it to the deck, and that's another point I should raise. This deck will be made available. We just got to do some edits before then. And so if you feel like you might have missed anything, we're going to have the recording of this with some obvious edits in place posted on YouTube. So you can refresh if there's anything you need to check out. The deck will be available as well, and we'll have all the relevant links in there.
I see Jose asked a question here. GDS to differential equations. Where does differential equation layer figure into this? So I'm not really a math person. That's not my background. As I understand it, these blocks can be thought of as transfer functions or differential functions. I don't know exactly what you're asking here. But this is a question that I can pass on to Z, who does have that formal math background, and I can get you a much more comprehensive answer than I would be able to fake, right? So yeah, I'll be sure to get back to you after I talk to Z about that. That's a question I can pass to him.
Awesome. Any other questions from the audience? If you want to speak up too, that would be great.
Can I just say one last thing too? The slides that Z was showing, I don't know if he mentioned this, but I just wanted to be clear that that code that he was using was some prototype code. Z and I have both been spending a lot of time trying to figure out or hone in on what an appropriate API would be that is sufficiently expressive, that's modular, but is also really, really, really easy to use and sort of easy to intuit about. And so the code that you saw there was similar to what we're going to end up with, but I don't want you guys to look at that code too closely and sort of expect that it'll be the exact same thing that you end up with in a month from now. It will potentially be different, but it should at least convey the idea that we want a more simple API so that modeling is easier and more accessible to more people, right?
It's pre-production. If you've seen a video game demo at E3, sort of like that.
Mm-hmm.
Cool.
Cool. Any other thoughts or comments that are popping up?
Nothing in the chat.
Awesome. Well, thank you so much. Can't wait to see all the faces here in our Discord, talking to us on Twitter. We're really, really excited by all this. All right. Thank you, everyone.
Awesome. And now we can jump over to the BlockScience Labs portion. So Fraser, I think I can just hand it off to you and let you present. Take it from there.
All right. Thank you for having me, everyone. And so let me just get set up here. You should be able to see a slide presentation. Yes? Okay. So hi, everyone. Thank you for having me. I'm Chris Fraser. I'm the CEO of BlockScience Labs. And so I wanted to go through just a couple slides real fast to explain, what is Labs? Why are we here? Why are we talking about this? And then we'll dive into a demo of the platform. So BlockScience Labs is creating an open core web platform where multidisciplinary teams can apply their scientific research to business analytics. Our goal is really to expand the use of the ideas that is being pushed by BlockScience and by using cadCAD. And we want to empower people to be able to use that tool and also focus on the other aspects of this line of work that we are all doing. Because it's not just about building machine learning models, it's really about the entire process from start to finish. And our platform is going to guide users, cadCAD users, into really focusing not just on the center of the process, but also on the bookends, because it is critical for you also in the beginning to properly form your problem, to really think about the risks and biases that might come into the modeling work that you're doing. And then on the opposite end is about that presentation layer. We're taking an angle of focusing on the business applications of using cadCAD, so that as you build your models, you're going to be needing to report this to clients, to executives, and there's really a need of a presentation layer that you can then translate the work that you're doing into the language that is more digestible by the people who are the high-level decision makers that are going to take the work that you did and have it make some sort of impact on the work that on the business. So how we're trying to make life easier for everyone is we're trying to create the cadCAD easy mode. We've talked to a lot of customers, and we've got an idea of how users are seeing some of these challenges with cadCAD. And the implementation of cadCAD 1.0 is going to address a lot of the challenges that we've heard from the actual, learning cadCAD and working with it. But there's a couple other things that people found challenging. One of those being when you want to share your code with others. So with labs, we're going to make it so that you have an environment where it's very easy to work together in one space without having some of the Python challenges of my code not running on somebody else's machine. The second is that we've created our own instance of a cloud infrastructure. So if you've been having challenges with running really big experiments on your local machine, we've made it so that it's very easy to pull your code into the platform and run it on the infrastructure, so you can run highly computational models in the cloud, parallelize, and get your results faster by using that. And finally, we're really focusing on that enhanced integrity. It's very important when you're doing this line of work that you can really have somebody else be able to verify your results, be able to reproduce what you're doing, and to really focus on the legibility of the work that you've done. Somebody else should be able to easily come in and be able to see what you've done and understand and go through your documentation and be able to verify it for you. So the platform is going to make it very easy for you to then document everything that you're doing and be able to share that work with others. So with that, I'm going to jump into a demo. So you should be able to see the sign-in screen. So from here, I'll go ahead and jump into the platform. And the first place you'll go to is the projects page. So you can think of a project as a container for all the work that you're doing for whatever your goal is. And it's really user defined. A project could be something for a client, it could be classwork, it could be a research project that you're working on with others. But whatever it is that your end goal is, the project will be the container for all of your code, for your documentation, and for your analysis and data that's all related to your end goals. And so in the short term, what we have is a one-to-one relationship between a project and a repo within GitHub. And if I wanted to create a new project, what I would do is first find the repo that I want to use within GitHub. What I've done is I've given the Labs platform connection to my GitHub account. So any repos that I have personally in GitHub, I can now pull into the Labs platform. So if I was just to go to my personal one, I'll randomly choose one of these. I'll pull in that repo. I'll give it a name. And then I can give it a description, which is optional. I'll just call it the digital twin, and then I'll create that. So it's as easy as that of bringing in that repo into the platform. Once I've done that, then there's a lot of things I can do within my project. And I'll actually jump into one that has more meat to it. So it's a little more interesting to show you what's going on. So within my project, now I've pulled in my repo, which if I click on this, it'll take me straight into my GitHub. And now I can run simulations in the cloud. So this particular repo is a digital twin of a hydroelectric dam that I built. And what it's doing is it's trying to answer a very basic question, that is, how long would it take to fill a reservoir behind a dam with water flowing through the dam and still need to contribute water downstream to the residents that live lower down the dam. So if I wanted to run a simulation that I've set up, I could click on Run Simulation and give it a name. I'll just call this demo. I can also select if I have multiple branches within my repo. I can at this point choose which branch I would like to run the model from, or run the simulation from. But you can also select the default so that you don't have to choose that every time. And then what happens is it's doing a check of my code. It's making sure that it's going to be running, and it's finding my system model. This takes about 15 seconds. And so once it goes through those checks, the other thing it's doing is it's creating a clean virtual environment in our infrastructure so that when this gets pulled in, it's going to be able to run without any challenges of it having anything to do with my local machine. So here's my system model. I'm going to go ahead and select that. And then the last step is giving me an estimate of how long it'll take and how much it would cost. The fee here is showing it's going to take about a minute and cost 50 cents. So I know how much it's going to cost me before I commit to executing this. So once I click execute, you'll see that I now have my new simulation on the list, and it's in the created status. Once this finishes, it'll look just like some of these others where I can download the results. So while that's running, let me show you some of the other aspects of a project. So the Files tab, this is where you can then go through all the documentation that's within your repo. And if you have a folder, you can have multiple breakdowns on the folder to organize your work. The access control allows you to bring in other users into your project, because one of our main goals is to have this be a collaborative environment. And the benefit here is that I can pull people into my labs project, even for private repos that I have in GitHub, so that I don't have to go and share access to my GitHub account or any other of the other Git repos that we'll start to integrate with in the future. I can have my collaboration be done in this platform without having to give access to the core repo that it is from. I'll skip over notebooks for a second here and jump to setting. This is just if I want to change some of the initial settings of this project. I can also at this point choose a branch as my default. In this case, it's kind of boring. I only have one branch in this repo, but this allows me to change that if I wish. If I go back to simulations, we should see that it's done. There we go. So you'll see that the one I just ran took 51 seconds. And at this point, I could download I really have two choices. I could download the results and work on this locally. So I've really taken advantage of the fact that I can run something really big in the cloud and then work with it locally. This particular model that I ran has 500 time steps and it's running 10 Monte Carlo runs. So it's not a huge model, but if I really wanted to expand this into being much bigger, I would be able to take advantage of this, run that really big experiment. And when it's done, I have the option of either taking out of the platform and working locally, or I could work on it in the platform within a notebook. So I'm just going to go ahead and download this so we can use it in a minute. So then let's say I wanted to work with this locally. What we've done is we've also integrated Jupyter Hub. And as of now, it's a very clean, vanilla instance of the Jupyter Hub, which will then continue to enhance over time. But what this allows me to do is now take the results from my simulations, and I can do all my work in the platform. It also allows me to share my work here with others. And so in this case, I have my repo here, the DAM model. And then this is everything we've already seen. So within here, I have documentation. So I'm able to have a markdown file that will share, my initial conditions, what's the purpose of this, why did I do this, so people have a better understanding of the model. But I'm also then able to have an analysis notebook, just like you would normally. And this is then this is like more of my combined, which will have as an easy way of doing a presentation layer is being able to hide some of the code, because you may have an audience that doesn't really want to see the Python. They really just want to see the charts and the results and the analysis that you've done. I can pull in the results that I just ran. If I was to come here and if I wanted to bring in a file, I could upload those results that I just ran. So there's my demo file, is my demo CSV, which I'm going to upload. And then now what I could do is run a new notebook. And with a little bit of code, then I can easily go ahead and pull those results into the notebook and start doing some analysis. I just want to show us, I'm just going to type it out because I want to show how simple it is for to be able to do this. So with this, I can then name what I call that file. And so I'm basically putting my results in a data frame, and then I'll print out that data frame. And so what this is going to do for me is when the data runs, it's serialized for compression purposes, but then we've made it so that if you pull this into the platform and use the BlockScience Labs import, it will unserialize that data for you so that you can then throw into a data frame and start to do your analysis. The last thing I wanted to show is you can create your profile. When you go into your profile, right now it's very basic with, you can put in your avatar, put in your name. We'll have a list of the different tools that you can join up with. But we also have some really big ideas of the way that we can add some more social aspects here, where you can really then start to take your work and be able to present it to others as your portfolio of the work that you've done on the platform. So that's a real high overview of what we have today for the platform. And what we're looking for is really to engage more with the community, to bring you on board to be able to try out the platform. So if you are interested in being one of our early users of the platform, I encourage you to go to BlockScience Labs and sign up. If you went to our website, all you have to do is click on the link to the form. And here you can then sign up with your email and be able to subscribe, and that'll get you on our list, and we'll get you onboarded to the platform. There's some benefits to that. We're not charging subscription fees while we're doing the testing, and we also want to give some benefits after launch to all the people that help us during the testing phase. And we will also be giving away free credits to run those simulations on the platform, because our goal right now is to really get your feedback on what works best for you and how we can really expand the user base of cadCAD through adding some of these other services. We also, which was discussed much earlier in the presentation, is we'll be participating in bounties where we will want to have some of the models that exist or new ideas for models be built that would work on the Labs platform. And we're also, we've been contributing to the development of cadCAD 1.0, and we will continue to do that because, again, we really want to see more people using cadCAD. So that's it for me. I'm happy to take any questions if there are any.
There has been some discussion in the chat. It's hard to tell what is comment and question. If anybody would like to speak up and unmute and ask live, that would be awesome. Otherwise, I can keep scrolling through and try and pull one out.
I'd just like to say Labs does plan on supporting both legacy cadCAD and cadCAD 1.0. So no matter which version you're using to develop your models, you should be able to run both on the Labs platform in the exact same manner. That's something that we want to be sure that we're supporting.
Yeah, absolutely. So when you come to a project and you're going to run your simulation, as more engines come into existence, you'll have the option of which engine you want to run. So right now we're using 4.27. I believe 4.28 will work as well. As soon as cadCAD 1.0 is out there, we will add that to the platform, so you can then choose between the two. And then other instances like the Rust implementation and the Julia implementation, and then whatever else is there in the future will be something that will integrate into the platform so that you can really then focus on the modeling work, and we've already made it easy for you to run it. Yeah.
Awesome. Any other questions? Cool.
Awesome. Well, thank you very much for having me. And I can also take questions afterwards. You can reach out to me. We have our contact at BlockScience Labs. And we also have several social channels that you can keep up with, subscribe to just keeping up to date on what we're doing.
Awesome. And do you want to drop the link in the chat so we have that? Is just blocksciencelabs.com. Is that it?
Yes. Yeah, I can drop that in the
place
chat.
to go. Cool. Awesome. Well, then I guess it looks like we'll be ending a little bit early. Thank you to everyone for joining today. It was a packed cadCAD community call, a lot of cool updates, and be excited to welcome you all back next month, and hopefully see you all around the Discord too in the coming weeks and days. And just reminders to fill out the interest form for the study group that was sent, and I'll do it one last time, and we will be in touch with more details. Cool.
Cool.
Thanks again to
guys.
everyone who presented.
Really cool presentation.
Thank you, everyone.